Second time I'm shooting this, the first one was kind of blurry. We'll start with the altitude of a triangle. We're on this page, altitude of a triangle. It is the perpendicular segment from a vertex to the line containing the opposite side. The orthocenter is the point of concurrency. Again, that's where the three lines meet. It's the point of concurrency of the three altitudes of a triangle. Remember, the circumcenter was the concurrency of the three perpendicular bisectors. The orthocenter is the concurrency of the three altitudes. Here are some pictures of some altitudes. The intersection of the altitudes of a triangle, if it's acute, notice it's inside the triangle. If it's obtuse, notice my orthocenter is outside of the triangle. Skip down. This is a good problem. It asks you for the orthocenter of the triangle with these three vertices. So we need to start by plotting those points, which we did. Slide over. There's J, there is K, and there is L. What I need is, again, I need two equations. I'm looking for two lines. I'm looking for lines perpendicular to this side, JL, which I can easily do. That's why I picked this side. This is a horizontal line. The perpendicular line is going to be a vertical line, straight up and down. It's perpendicular. There is, what is the equation of that line? It is x equals -2. Now I got some work to do. I want the equation of this line. Notice I want to figure out the slope of KL first, which I can do here. Remember, slope is y2 minus y1 over x2 minus x1. The slope of KL, using K and L, it's 2 minus 6 over 2 minus -2, which is -4 over 4, which is -1. The slope of KL is -1. Do we remember what is the slope of a line that is perpendicular to it? What's true about the slopes if my lines are perpendicular? I should be able to multiply them and it will give me -1. So the slope of a perpendicular line to KL is 1, because -1 times 1 is -1. And that line, it must also pass through -4, 2, which is right here, because that's the vertex. Remember, the altitude is a perpendicular segment that goes through the vertex of the other side. So I have y equals mx plus b. I want an equation. There's y equals mx plus b. But I know what y is because I'm using this point. So y has to be 2. I know what m is. M has to be 1. We just said the slope was 1. I know what x is. We said we're using this point. So x is -4 plus b. That allows me to solve for b. b is equal to 6. So my equation of this line is y equals x plus 6. The equation of that one is x minus 2. Now I'm looking for the point. Now, of course, I can see it. I can see where the orthocenter is. It's at -2, 4. But if I can't see it, maybe it's off the graph, I go back to my equation. I have y equals x plus 6 from this equation right here. But I just told you that x is equal to -2. So just plug in -2 for x. Y equals -2 plus 6, it equals 4. So I have x equals 2 when y is equal to 4. Orthocenter, -2, 4. I understand it's a lot of steps. I get it. We'll do more of these in class. Just be familiar with it. Another type of circle center. So we have something called the incenter of the circle. The incenter of the circle is the point of concurrency of the three angle bisectors of a triangle. So if I bisect all three angles, where those three bisectors touch, where they meet, that is called the incenter of the triangle. If you need to pause, pause. Inscribed, what does it mean to be inscribed? It's a circle in which each side of the polygon, in this case a triangle, is tangent to the circle. Tangent means it touches in one spot. So I have a triangle basically trapped inside of a circle. We'll talk more about that later. So there's a picture. There's my incenters. Again, the incenters, my incenter is where my angle bisectors meet. Notice it says the distance from my incenter to the sides of the triangle are all the same. Think about how that's different from the circumcenter. Go down, we got a good little picture. Unlike the circumcenter, the incenter is always inside the triangle. I did one. There's my acute angle, there's my incenter. Gives you a good little problem here. It tells you you have a church, you got, what is this? Did I say what the buildings are? Maybe a school, office building. It wants to put fireworks equidistant from all of these places. I should be thinking circumcenter. So if I do, I just trace this on my patty paper like we did in class. I then folded it up. I found all my perpendicular bisectors, and I found my circumcenter. And if I fold it up, I should put it here. This is where my fireworks display should go if it's going to be equidistant from all three locations. Again, we'll do more of that in class. Last page, last circle center. We have a new thing. We've talked about bisectors, perpendicular bisectors, altitudes. We have medians too. The median of a triangle. It is the segment whose endpoints are a vertex of the triangle and the midpoint of the opposite side. So it goes from the vertex of one of the vertexes of the triangles to the other side, and when it hits the other side, it hits that side at its midpoint. The centroid of a triangle, another point of concurrency, but this one is where the three medians hit. We also call this the center of gravity. Point of concurrency of the three medians of a triangle. What's different about a centroid? Notice the centroid of a triangle is located 2/3 of the distance from each vertex to the midpoint of the opposite side. Kind of a mouthful. Let's talk. VP. VP is right here. VP equals 2/3 of PT. So VP is 2/3 of the way all the way through. Same thing with VR. VR right here. So R from R to V is 2/3 of the way from R to S. And VQ, the same thing. VQ 2/3 of the way all the way through. Let's use that and let's do a problem. I have AG. It tells me, I'm looking for AG. Slide there. I'm looking for AG. It tells me AF is 9. Now if I look at the picture, I should see that I have a median. I've got centroid. AG is equal to 2/3 of AF. AG 2/3 of the way to AF. And I know what AF is. So AG is equal to 2/3 of 9, which is 6. AG's got to be 6. This next one's a little bit more complex. It wants CE. It wants to know how far it is from C to E. CG is equal to 2/3 of CE. Again, CG is right there. It's 2/3 of the way all the way through, which is CE. But I can do CG plus GE equals CE. So this segment plus this segment equals the whole segment. And then I just substitute. Up here I said that CG was 2/3 of CE. So instead of putting CG, I'm going to put 2/3 of CE. I just substitute it in. Plus GE equals CE. Subtract 2/3 CE from both sides. That goes away, and I'm left with GE equals 1/3 CE. Come up here. Notice that GE, they told us up here, was 2.4. So instead of putting GE, I'm going to put 2.4. Equals 1/3 of CE. Multiply both sides by 3. 7.2 is equal to CE. A mouthful, I know. We'll talk more about these. Just be familiar with it.